Imagine waking up at 3 a.m. from a strange thought. You walk to the window, look at the city, millions of lights, skyscrapers, roads, and suddenly realize, in 100 million years, nothing will remain of all this. Our cities will turn into a thin layer of sedimentary rock. Plastic will decompose, concrete will crumble, steel will rust and dissolve. Even our bones will turn to dust. And if a new intelligent species appears on this planet in 100 million years, they will look at the layers of rock and find no traces of our civilization. Maybe a strange concentration of carbon in one layer, maybe an anomaly from isotopes, but skyscrapers, the internet, nuclear weapons, nothing. Just the silence of stone. Now, let's turn this thought in the opposite direction. The Earth is 4.5 billion years old. Life on it has existed for 3.5 billion years. Homo sapiens for only about 300,000 years. Technological civilization for just 10,000 years. Industrial for 250. This isn't even a blink in geological terms. It's a camera flash in the darkness of eternity. And here's the question that made me set aside my laptop and stare at the ceiling for 3 hours. What if we're not the first? What if there were civilizations before us that built, invented, fought, dreamed, and vanished, leaving nothing but geological anomalies that we attribute to volcanoes and asteroids? I'm not a mystic. I'm not a fan of ancient astronauts or Atlantis. I'm used to trusting data, not legends. But when I started digging deeper, I came across a scientific article by two physicists, Gavin Schmidt from NASA and Adam Frank from the University of Rochester. The article was called The Silurian Hypothesis, named after a race of reptiles from the TV show Doctor Who lived on Earth before humans. But this isn't fiction. It's a serious scientific paper published in a peer-reviewed journal. And its essence is simple to the point of horror. We have no reliable way to detect an industrial civilization that existed on Earth more than a few million years ago. I decided to test this hypothesis. I loaded terabytes of geological data, paleontological reports, and isotope anomalies from the last 500 million years into the neural network. I gave the AI a clear instruction: ignore conspiracy theories. Look only for facts. Find traces in the rocks that an industrial civilization could have left. And here's what the algorithm outputted. But before I show you the result, we need to address 3 questions. First question: what even remains of a civilization? We're used to thinking that our skyscrapers, pyramids, the Great Wall of China are eternal, but geology is cruel. The Himalayas rose in the last 50 million years. The Atlantic Ocean opened 180 million years ago. Plates converge, diverge, consume each other. Subduction, the process where oceanic crust sinks under continental crust, destroys rocks without a trace. In 100 million years, most of the ocean floor will be recycled by the mantle. In 200 million years, continents will merge into a new supercontinent and split apart again. The entire surface of the planet will be plowed by plate tectonics like a field by a plow. What will remain? Geologists say a thin layer of sedimentary rocks with anomalies, a spike in carbon concentration, a peak in certain isotopes, strange ratios of metals. Perhaps microplastics will turn into a special type of sedimentary mineral, a technofossil, but it will look like a millimeter-thick layer in kilometers of rock. How do you find a needle in a haystack the size of a planet? Especially if you don't know what you're looking for. Second question: what anomalies should we be looking for? I asked the AI to model the geological footprint of our civilization. Imagine humanity disappears tomorrow. What remains in 50 million years? The neural network produced a list of 8 markers. First, carbon spike. We've burned trillions of tons of fossil fuels in 200 years. All that carbon entered the atmosphere and settled in sedimentary rocks. Second, isotopic anomaly. Nuclear weapons, atomic power plants, medical isotopes. All this will leave a trace in the form of strange ratios of isotopes of uranium, plutonium, cesium. Third, plastic layer. Microplastics have already been found in deep-sea sediments. It could become a marker horizon, the Pleistocene. Fourth, metallic anomalies. We've extracted billions of tons of aluminum, copper, rare earth elements from the Earth and scattered them across the surface. Fifth, concrete and ceramics. They're durable, but in tens of millions of years, they'll turn into strange mineral inclusions. Sixth, biosphere changes. Mass extinction of species. Seventh, erosion changes. Agriculture has washed away the topsoil faster than it happens naturally. Eighth, nitrogen imbalance. Fertilizer production via the Haber-Bosch process has altered the planet's nitrogen cycle. Okay, the list is ready. Now the question, do we see anything like this in the past? And this is where it gets most interesting. The AI analyzed the geological record for the last 500 million years. This is the period when complex life already existed on land. Plants, animals, a potential window for an intelligent civilization. And the algorithm found several anomalies. They don't prove the existence of ancient civilizations, but they don't rule them out. First anomaly, Paleocene-Eocene thermal maximum. 56 million years ago, in just 10 to 20,000 years, the planet's temperature jumped by 5 to 8 degrees Celsius. Mass extinction began in the oceans. In the sedimentary rocks of that time, there's a sharp spike in carbon-12. Classic explanation: volcanism, methane from the oceans. But the AI drew my attention to a detail. The rate of carbon release is comparable to our industrial era. This isn't proof, but it makes you think. Second anomaly, Ordovician glaciation 450 million years ago. Sudden cooling, mass extinction. In the rocks of that period, strange isotopic ratios are found. Some geochemists call them inexplicable. Could this be a trace of industrial activity? We don't know. The problem is that in 450 million years, most rocks from that time have been recycled by tectonics. Third anomaly, Devonian extinction. 375 million years ago, 70% of species went extinct. The cause is unclear. In the rocks of that time, elevated concentrations of mercury and other heavy metals are found. Volcanoes, perhaps, but there's another detail. In the Devonian, the first forests appeared. Trees began massively burying carbon in the soil. This radically changed the atmosphere. Oxygen content jumped to 35%. What if someone back then learned to use that oxygen for industry? What if they burned so much carbon that they triggered a climatic collapse? I know what you're thinking. This is too bold, too speculative. And you're right. But let's look at the problem from another angle. I asked the AI, assume there was an industrial civilization on Earth 100 million years ago. How long would it have had to exist to leave a trace we could find today? The algorithm calculated several scenarios, and here's what came out. Scenario 1. The civilization lasted 100,000 years. That's 10 times longer than our industrial era. If they burned fossil fuels, built cities, mined metals, there should be a noticeable but short carbon spike and metallic anomalies in the rocks. Problem: such a spike is easily confused with natural events, eruptions of supervolcanoes, asteroid impacts. Probability of detection, about 30%. And only if the civilization existed in the last 100 to 200 million years, while the rocks haven't been fully recycled yet. Scenario 2. The civilization lasted 1 million years. That's a serious timescale. Their trace would be deeper. Multiple carbon spikes, global climate changes, mass species extinctions. But if this was 200 to 300 million years ago, most rocks from that time are deep underground or already destroyed by subduction. Probability of detection, 50 to 60%. If we know what to look for. Scenario 3. The civilization lasted 10 million years. This is a scale that's hard to imagine. Homo sapiens has existed for 300,000 years. 10 million years is the time in which entire families of mammals appear and disappear. Such a civilization would leave a massive trace. But here's the problem. If they lasted that long, they probably solved the problem of sustainable development, switched to renewable energy, stopped mining fossil fuels. Their trace would become invisible. Probability of detection paradoxically low, about 20%. The more successful the civilization, the fewer traces it leaves. The third question is the most important, and it's psychological. Why do we so want to believe that we're the first? Why does the idea of ancient civilizations provoke such resistance? I loaded psychological studies on cognitive biases into the model, and it highlighted 3 reasons. First, anthropocentrism. We want to be unique, special, the crown of creation. The thought that someone before us already walked this path and vanished hurts our ego. Second, fear of meaninglessness. If civilizations arise and vanish without a trace, then everything we build will also vanish. This is existential horror. Third, professional pride. Geologists, paleontologists, archaeologists have spent centuries studying the past. The idea that they might have missed something is perceived as an insult to their competence. But science isn't about defending pride. Science is about asking uncomfortable questions. And here's one such question. We're searching for life on other planets. SETI scans the sky for radio signals from extraterrestrial civilizations. We send probes to the moons of Jupiter and Saturn, hoping to find microbes under the ice. But at the same time, we're confident that on our own planet, over 4.5 billion years, intelligent life has appeared only once. And that's us. Statistically, this looks strange. The Earth has been habitable for most of its existence. Complex life has existed for the last 500 million years. Why, in that time, has intelligence appeared only once? I asked the AI to calculate the probability. I gave it parameters: the duration of the biosphere's existence, the speed of evolution, the number of mass extinctions, time windows for the development of technological civilization. The algorithm produced several models. In the optimistic model, where intelligent life arises relatively easily, there could have been 3 to 5 technological civilizations on Earth in the last 500 million years. In the pessimistic model, where intelligence is extremely rare, we really are the first. In the average model, 1 or 2 civilizations before us. But here's what's interesting. The AI drew my attention to a pattern. After each major extinction, Permian, Triassic, Cretaceous, Paleogene, life recovers and takes a new evolutionary path. Dinosaurs dominated for 160 million years, then an asteroid, then mammals. What if there was another cycle before the dinosaurs? Reptiles appeared 300 million years ago. They had 100 million years before the dinosaurs appeared. 100 million years, that's more than from the extinction of the dinosaurs to us. Could some branch of reptiles have developed intelligence, built a civilization, and then vanished in the Permian extinction, which wiped out 90% of all life? We don't know. That's the honest answer. We don't know because we don't have the tools to check. The geological record isn't a video recording. It's fragments, scraps, random frames from a 4 billion year film. 99% of all species that ever lived on Earth went extinct and left no fossils. The chance of becoming a fossil is 1 in a billion. The chance that this fossil will be found and identified is even smaller. Now imagine the chance of finding a fossil of a creature that lived 200 million years ago, was intelligent, but left no bones, only tools that have long since decayed. I asked the AI for analogies on how else we could search for ancient civilizations. The algorithm suggested 3 approaches. First, search for technofossils. These are fossils of artificial objects. Imagine someone 200 million years ago made ceramics, smelted metal, built with stone. Some of these materials could have survived as strange mineral inclusions. Problem: how do you distinguish an ancient hammer from an unusual rock? Without context, you can't. Second approach: search for geochemical anomalies in deep layers. Not just carbon spikes, but complex patterns.
Métal plus carbone plus isotopique shift plus masse extinction.
Altogether. Third approach: search for traces of megastructures. If the civilization was advanced enough, they might have built something massive. Dams, canals, underground structures. Some of them could have partially survived in deep geological layers. But again, how do you distinguish an ancient canal from the bed of a dried-up river? This is where the main point begins. I reached the point that flipped my understanding of this topic. I asked the AI, assume we find evidence of an ancient civilization, what does that change? And the neural network gave an answer I didn't expect. It said, if there were other civilizations on Earth and they all vanished, that points to the existence of a great filter. The Great Filter is a hypothetical barrier that prevents civilizations from developing to a certain level. It could be nuclear war, climatic collapse, resource depletion, artificial intelligence out of control, a pandemic, an asteroid, a supervolcano. If we're the first civilization on Earth, perhaps the Great Filter is behind us. We've passed it. If we're not the first, then the filter is ahead. And all previous civilizations crashed into it. This is sobering. Suddenly, all those carbon spikes, mass extinctions, climatic anomalies, they're not natural disasters. They're the graveyards of civilizations that failed, that burned all the fuel, overheated the planet, exhausted resources, and collapsed. And we're now repeating their path. We're burning carbon faster than they did, changing the climate in a century, not a millennium, exhausting non-renewable resources, building weapons capable of wiping us off the face of the Earth in 45 minutes. Maybe the Silurian hypothesis isn't about the past. It's a warning about the future. I asked the AI to calculate, if there really were previous civilizations on Earth, what lessons can we learn? The algorithm produced several patterns. Lesson 1. Civilizations are fragile. No matter how advanced they are, one catastrophe can reset everything. Lesson 2. Technological growth without ecological sustainability is a path to nowhere. Lesson 3. The faster a civilization develops, the higher the risk of collapse. We've gone from the steam engine to quantum computers in 200 years. That's insane speed by historical standards, and the faster you fly, the harder you crash into the wall. But there's another side. If previous civilizations existed and vanished, that means the planet recovers. Life continues. The biosphere has survived 5 mass extinctions and each time reborn. Even if humanity vanishes, in 10 million years, the planet will heal its wounds. In 100 million years, new species will appear, new ecosystems, perhaps a new intelligent species. This isn't comforting, but it shows the scale. We're not the center of the universe. We're not even the center of Earth's history. We're an episode, a short flash. The question is only what trace we'll leave. The trace of a civilization that understood its fragility and learned to live in balance, or just another carbon spike in a layer of sedimentary rock. Now let's gather everything into a basket of versions. We have 4 main hypotheses. Version A, skeptical. There have never been technological civilizations on Earth before humans. All geological anomalies are explained by natural processes. We're the first and only. Probability according to the AI, 45%. This is the most conservative position, and it aligns with the current scientific consensus. Version B, cautious. Possibly, there was one previous civilization in the very distant past, 300 to 500 million years ago. Their traces are almost completely erased by geological processes. Some anomalies might be their legacy. Probability, 30%. Version C, bold. There were several civilizations, 2, 3, maybe 5, in the last 500 million years. Each reached a certain level of development and vanished due to climatic collapse or other catastrophes. Probability, 20%.
Version D. Fantastique.
There were highly advanced civilizations that existed for tens of millions of years and became ecologically sustainable. Their trace is minimal precisely because they learned to live in harmony with the planet. Possibly, they left Earth or evolved into something we can't recognize. Probability, less than 5%. Which version is correct? We don't know. But here's what I know for sure. This question is important. Important not because we need to find ancient ruins or prove the existence of a reptile race. Important because it forces us to think about our own future. If we're the first, we have colossal responsibility. We could become the civilization that breaks through, survives, spreads into space as pioneers. If we're not the first, we need to understand what destroyed those before us and not repeat their mistakes. Remember the 3 questions I asked at the beginning. First, what remains of a civilization? Answer, almost nothing. A thin layer of anomalies in kilometers of stone. Second, what anomalies should we look for? Answer, complex patterns. Carbon, metals, isotopes, extinctions all together. Third, why is it important for us to know this? Answer: because it's a mirror. By looking into the past, we see our possible future. So how many civilizations existed on Earth before us? I can't give you an exact answer, but I can say this. The probability that we're absolutely the first in 4.5 billion years is statistically suspicious. The probability that there were many is also low, because we don't see obvious traces. The truth is probably somewhere in the middle. 0 or 1 previous attempts. Maybe they were short, several tens or hundreds of thousands of years. Maybe they didn't reach our level of development. Maybe they were intelligent but not technological. Maybe they were so different that we simply don't recognize their traces. For the skeptic, the conclusion is this: there are no direct proofs of ancient civilizations, but absence of proof is not proof of absence. The geological record is too fragmentary to be certain. The question remains open, and that's okay. Science isn't obligated to have answers to all questions right now. For those who believe in the possibility of ancient civilizations, there are intriguing hints, but deeper research is needed. For all of us, one common conclusion: we live on a planet with a long and complex history, most of which we don't understand. Here's a practical tip. Next time you hear about another geological anomaly, a climatic shift in the past, or a mass extinction, ask the question: could this be a trace of intelligent activity? Don't accept automatic explanations. It was volcanoes or it was an asteroid. Stay curious, stay critical. And remember, the most dangerous thing in science is the certainty that we already know everything. If what we've discussed today resonates with you, write in the comments: we're not the first. Just so I know how many of us there are. People ready to ask uncomfortable questions. Give it a like. It helps the algorithms find other seekers. Subscribe to the channel if you're here for the first time. We break down complex topics into atoms. No esotericism, no conspiracy theories, just data and questions that have no answers yet. And finally, when you go to bed tonight and look into the darkness, think about this. Maybe somewhere in the depths of the rock layers, kilometers beneath your feet, there's a thin layer, just a few millimeters, in which the history of an entire civilization is recorded. Its cities, wars, love, art, dreams, and no one will ever know they existed, except for one thing: they vanished. Don't repeat their fate. Live as if your trace is the last chance for reason on this planet to leave something that matters. Until next time. If there is a next time, we're only saying goodbye in this world.